Bismillahirrahmanirrahim. Assalamu alaikum. My name is Muhammad Asim. I'm working as DevOps engineer. Guys, in this video, I'm going to show you how we can use the EKS blueprint submodule. So why we are using the submodule instead of the actual module? The reason is that we are going to simply integrate the submodule with our existing EKS managed module. So in my past videos, I've already covered how you can set up the EKS cluster through the manage modules. If you haven't watched those particular videos, you can watch those particular videos regarding the EKS setup. So let's begin. In this video, I'm going to cover how we can install the ALB Ingress. The EBS setup is going to be automatically done with this manage module of EKS. So we are going to install the Karpenter and we are going to set up the two groups regarding the management of EKS cluster. One is going to be the EKS admin group and other is going to be the developer group. So first thing first, what we are going to do simply, if you navigate to this section, what you need to do is simply copy this URL and simply clone this repo. So if I do ls here, nothing is there. It is mounted on my Windows host machine. Simply what I'm going to do, I'm going to clone this guy and then I'm going to open this guy in my VS Code. So simply open this in VS Code. I just want to show you that what we are going to do regarding the backend, which is S3 bucket. I've just actually commented out. So as this is the sandbox environment, I've shown you how you can set up the backend. For that, you need to create the S3 bucket. So for this demo, make sure you have installed AWS CLI and Terraform. So I've already installed everything in my container. So regarding the environment setup, I've already made videos how you can set up the environment in containers. So you need to simply install that, run that particular script, and all the relevant packages are going to be installed for you guys in that particular container, right? So the reason for setting up the environment in container is that your actual host environment is not going to be polluted. So regarding this setup, let me do first of all do Terraform init and Terraform apply. Then I'm going to demonstrate what uh, we are going to do and how we are going to set up all the thing. So regarding the setup, it is going to be pretty much easy. What you need to do is to simply do Terraform init, and then I'm going to do Terraform apply dash auto approve. So what it, currently it is doing, it is going to set up the local backend for us, and it is going to initialize by downloading all the relevant module for us. Until then, I'm going to do the demonstration. So let me do navigate to this particular section in the main TF, right? So if you see in the main TF, what we're going to do, we are just making sure that AWS CLI install and Terraform definitely should be there. And then we have required provider, which includes the AWS kubectl, Helm, and of course Terraform version. More than one is going to be okay. So this is the backend. As I discussed, I've commented out this section as this is the demo, so I'm not going to cover all the basic stuff here. So this is the locals. This is the name of the cluster, and the cluster version is going to be the latest version provided by AWS. So this is the VPC module. So in this VPC module, we are going to use this version. And this is the official managed module from the official Terraform so registry, and simply need to Google it and navigate to the Terraform registry and you will find this module. So everything is pretty much the same as I covered in my previous videos. This is the side ranges, private, public subnet, and database subnet ranges, right? And DNS host names are enabled. So these are the tags with regard to the, for instance, this is regarding to the internal ELB, and for external ALB, we need this tag, right? And some of the tags are regarding the Karpenter. So I've already added that. So local cluster name is going to be picked up from that particular variable which we have set in on the top. So let's see how much has been done. So it is currently downloading all the relevant packages, in fact, modules. So if I navigate to the main directory, you will see the .terraform directory is going to be created, and everything is going to be downloaded from remote to the local. So if you navigate to the Terraform, this .terraform, which is the hidden directory, is there, and you see all the relevant module from the remote is currently in and downloading state. So then if I navigate to the section regarding the EKS cluster, this is the managed module from the official Terraform registry. So this is the version we are using. So as I told you, we are not using the official module. So let me navigate to the section where I'm talking about the official module regarding the EKS blueprints. So let me just navigate to that section and simply, okay, this is the add-on module which we are going to use. So let me show you some of the stuff that every link I've already added. So you can simply see, or you can see a lot more detail. So this is the official module regarding the EKS blueprints. So instead of using that, we are going to simply use the module because we just need to install some of the packages which are actually more of a wrapper regarding, you know, the Helm charts. So you can manually install as well. I mean, for instance, if you navigate to my Google videos, which I've created in past, if you want to set up all the stuff manually, you can do that as well. But it gives us an ease of use. That's why I'm not using the complete module. I'm using the sub module. So this is the EKS Blueprint official module. So if you navigate to the release section, you see this is the latest release, but we're not going to use that. Instead of, we are going to use the official EKS module. And what we're going to do, we are going to simply use the module, which is this is the add-on module. So let me copy this guy and simply, okay, this one is, I've already opened it. So this is the one. Everything regarding the, I mean, documentation is there. What entries or what inputs you need are going to be available here. So let me close that, and definitely the version is going to be, as this is the sub module. So where the version reference is going to be the same as of the actual module, right? So this is the add-on module. We are simply we are going to simply integrate that particular module to our EKS cluster, right? So this is our EKS cluster name, endpoint ID. So where I'm getting all these values, I've already shown you from the Kubernetes add zone. You can simply see all the inputs values from there. So some of the examples you can see from here as well. So simply copy this guy and navigate to this section. And some of the examples you can see from here as well. So I've already added this stuff from here. So all the examples, for instance, you see these are the inputs we have taken from the official stuff. So just the Karpenter example I'm quoting here. So just to give you an idea what we are going to do, and we are going to simply integrate. How we are going to integrate, examples and links are already there from the official documentation, right? So this is the stuff we are going to do. Let's see. It is currently installing all the modules. It is done. So we are going to simply do apply auto dash approve, and then I'm going to give you more detail regarding that what we're going to do. It will take about 15 to 20 minutes. Everything is going to be done. So let me navigate back to the section from the start, and let me start from the EKS VPC. So as I discussed, this is the basic stuff. We are going to set up the custom VPC. In this particular custom VPC, we are going to install our EKS, set up our EKS cluster, right? And this is the EKS cluster module. So in this official AKS module, what we're going to do, we are going to provide the name, plus the version, which is going to be latest VPC IDs, subnet IDs. And you see subnet IDs are going to be the private subnets, which means that our custom manage, sorry, our must custom, in fact, our managed node groups are going to be deployed in these private uh, subnet groups, right? So enable IRSA is the OIDC, right? And um, private access point and public access point set to true, so we can access from our remote machine to that particular remote Kubernetes cluster, right? So, as I discussed, that we are not going to use install EBCSA driver, because by default, if you use this particular latest official EKS cluster module, so you see EBCSA driver is already there, and these cluster adds on, you see core DNS and kubeproxy EBCSA driver, you can get now by default. So we are not definitely going to install these. Another additional rules which we need for instance, we need to use, we need for the Karpenter to in order to communicate. So these are the ports 8443, right? And no additional security groups rules by allowing the ingress rules, everything from 0 to 0. I mean all is allowed inside for which is which is the self, right? And egress traffic, right? So this is the pretty much the basic stuff. So these are the timeout values, and other create IAM role true EKS. We are going to create a IAM role. So guys, other stuff is regarding the creation of IAM role. You can give this particular role name. Um, if you want to set up, this is required for the cluster creation, and the security groups to everything is pretty much there if you navigate to the EKS module. So detail regarding that particular module is already there. You need to navigate to this section. If you navigate to this section, simply copy this guy, and regarding every input, you can see all the detail what each input can do. Definitely you can read all the documentation. Definitely it is not possible for me to cover every input. All right, so okay, simply okay is the let me simply type this module. Navigate to Google. That's google.com. Okay, and simply type Terraform EKS module. That's it. Simply copy this guy, and this is the module, right? So this is the module. This is the module EKS. So you need to copy this guy, and the same stuff we have done there. So this is the version, and these are the inputs I'm talking about. So what you need to do if you want to read, see all the documentation, you see these are the inputs and the description of those inputs. So simply you can navigate to this section, and if you want to see a lot more details, you see a lot of inputs. And if you want to see the details regarding this particular module, so simply scroll up, click this guy. You will be navigated to this GitHub section where you will see all the examples of that particular section. So click on examples. You will see complete example, or you want to see all the stuff so you can get more details, how to use it, what has been done. So this I need to show you. So simply navigate to my channel Cloud Geeks. Okay, so simply navigate to the section. As I in past, I have manually shown you how you set up the ALB Ingress controller, how you can do the cost reduction with this Karpenter. So all the installation we have done manually. and now we are going to use the managed sub module, right, instead of using the full module, because we need to simply install these stuff in an automated way through the Terraform. And this is the other stuff and other videos if you will, I mean, definitely need other stuff to see regarding the EKS, GKE, RabbitMQ cluster. You can simply do that. So that's it regarding that, what we are going to do. And then if I scroll down, then we are going to simply, uh, as I discussed, do the cluster adds on, port DNS, proxy, EBSC site driver, and these are the additional rules regarding the security groups which we need for the Karpenter and there I've already discussed. So, okay. So this is the sub module inside that EKS module, which we are actually using in the EKS module. See, currently the cluster creation in progress. So if I navigate to this section, Kubernetes EKS, so simply click this guy in the new tab, you will see that the version 1.25 currently in the installation process. As I told you that it will take about 15 to 20 minutes. Till then, I'm going to do the demonstration that what we're going to do. We are going to use the EKS managed node groups, right? The name of one node group is going to be the on demand, and we are going to use the uh, our custom launch templates. So additional IAM policies which are actually required by uh, Karpenter. So for the sake of make things work right, we have already added these AWS managed policies, right? So and then this is the min max size I have already set up. So regarding the instance type, as this is the demo, I'm going to use the 3T3A T3 medium, sorry, uh, the tongue twister. So and this is going to be the on demand, and subnet IDs are going to be private. Create launch template true, enable monitoring. If you want to simply don't want this, you can simply uh, set it to false because it will take some additional costs. So EBS optimize true, and this is the volume type is going to be GP3, volume size is going to be 50, and additional stuff I will added. So I've also added something with regard to the security best practices that our disk should be encrypted. And even one thing I would like to share regarding the secrets of EKS cluster. If you click this guy, secrets are going to be secrets encryption is on. You see, from the security perspective in the Kubernetes, secrets are going to be encrypted at rest. So our disk EC2 disk are going to be encrypted. Our this area of secrets are going to be encrypted as well. So this is something with regard to the security best practices, and then the spot. And the other thing, we are not going to actually use that, but that is how you can add the second, you can say that managed node group. So this is how you can add it. So currently I set up the min max size, I mean desired size and min size to 0. So pretty much the same stuff, but you see the main difference is the capacity tab is going to be the spot. And this is also very much the area that we are going to use the manage auth config to true, because we are going to use these two auth roles, right? One, as I discussed, one is going to be the EKS system admins, and other group is going to be our developers. So if I navigate to the section, this is actually going to be created. So simply navigate to this section, excuse me, IAM, and you will see the two groups has two policies, STS policies, right? And in those STS policies, you will automatically, Terraform is going to attach those particular roles. So if you navigate to the users groups, you see automatically it has created EKS admin, Cloud Geeks EKS dev. This is our name of our cluster. So that's why I did in a way that if you have multiple cluster in same account, you can have, no issues by the creation of these groups. So you can definitely, this name is unique. So I've added the variable with these names, right? So let me, let me go back to where we left. So these are the stuff we need for our developers and our sysadmins. So as I'm the owner of these clusters, I have full access. And if you want to give full access to that particular user, simply what you need to do, create a user and simply add that particular user uh, in that particular group, EKS admin, and the configuration with regard to that particular user I've covered later in my video. So this is where we are creating the EKS admin groups through the Terraform. These are also managed modules. So this is where we are creating the policy, right? EKS admin group. We are setting up the policy, describe cluster, right? And then this particular role is also from the AWS managed role. In this particular role, we have given this EKS admin. As I discussed, I've used the local cluster name. This is the variable which I've used to make sure that every name is unique with that particular cluster. So creation of a role is going to be true, and the above policy which we have created from the top is going to be this one. We have used the ARN here, and trusted role ARN is going to be, the account ID and root. So uh, then this role is going to be set up. Then we are going to set up the custom policy, and which is also through the manage module. And in that particular custom STS policy, we are going to provide the ARN of that, which we are ARN of that particular role which you've created above. So you see, this is the custom policies, right? This is the JSON code, and in that we have actually provided the role which we have created in step two. So to make things understandable, I've used step one, step two, step three, and you see in step three we have provided the step two role which we have created in step two. So in step four, simply what we are going to do, we are going to create one group, right? So this is step four. So in this step four, which is the creation of group. So this is the creation of group. For instance, this admin group and developer group. So if I click this guy, you will see one policy is going to be attached. So if you navigate to the permissions section, you'll see this particular policy, assume role policy, is going to be available. So I've designed this module in a way that when you want to add a user, simply create a user from the UI and manually add that particular user in this group. That's it. So it will not affect any Terraform or something like that. So simply anyone with no knowledge of IAM, simply create user and simply add that user to this group, and that particular user has admin access or developer access, right? So okay, this is pretty much done, and similar stuff I've done for the developer. Same step number one, step number two is going to be there. So I'm not going to cover the same stuff, but this is pretty much the same stuff. So the developer access are going to be a little bit different in a way that, let me show you that. So in a while, so I will cover that. So currently we are in that phase. So let me finish that part. So if you navigate to the Terraform section, click this guy. Okay, so if you click this developer section, so if you click this reader.yaml, what reader.yaml is that it has the cluster role and the cluster role binding. So in this particular section, this is the reader, and this has these verbs. You can say that, or the permission which you have granted regarding the pod logs. The developer wants to see the pods logs. There we can do the cost reduction in a way that, for instance, if you have dev staging environment, you can do the cost reduction that you will not going to set up that particular logs, which I have covered in my previous video. For instance, in production, you can set up the Kubernetes logs through the Elasticsearch. And let me navigate to this section, Cloud Geeks. Okay, so click this guy and navigate to the video section. So let me scroll and okay, so let me do okay, think Nginx cost reduction. Yeah, Terraform Kubernetes logging with Fluentbit and Elasticsearch. If you want to see the detail regarding the how we can set up the production setup, you can see this particular video how we can set up that.
Waiting with the
But in this section, we are going to use a strategy like in staging a dev environment. We are not going to set up that particular Fluentbit and Elasticsearch. In fact, what we are going to do, we are going to provide access to our development team. Instead of setting up that, we are going to provide this particular access to see their logs, and we are going to set up the lens on those particular machine, so they can easily get the logs of that particular deployment or their application. So I'm going to show you later. So this is what we need to apply. So if you navigate back to the section, you see uh, where we are. Let me scroll a little up to that particular group. So if I navigate to the EKS section, you see this is the EKS admin. So this is the reader regarding that particular IAM group, and then we are going to simply do kubectl apply to give this permission. So it is going to be created. So where we are, everything is set up for us. You see, you have done Terraform init, and I have done Terraform apply auto apply to do all deployment to do all the deployment. Everything is pretty much set up. So what we are going to do, first of all, let me show you that our EKS cluster should be set up. So simply click this guy and you will see that everything is set up for us. And what we are going to do, first of all, we are going to create an IAM user, and we are going to use these particular commands. And let me do one stuff here. So what I'm going to do, okay, so um, I'm going to simply import this cluster EKS update cube config. Name of the cluster is Cloud Geeks EKS Dev, and the region is going to be US East 1. So you see, the context has been imported. kubectl get nodes. You will see two nodes, right? So what I'm going to do, I'm going to do simply bring this guy to my in fact, one thing I would like to share with you guys. Okay, what I'm going to do, I'm going to navigate to the developer section, right? And simply what I'm going to do, I'm going to do kubectl apply -f reader.yml. So let me do that. So it is to the cluster role, set up the cluster role and cluster role binding. in that reader section. So it has two parts. You see that one part is regarding the AWS, and another part is inside the Kubernetes cluster. So inside the Kubernetes cluster, we have applied that part to make sure that particular user, for instance, we are going to create one user, and we are going to, let's say this user is going to be the developer, and this guy is the cloud user, is the admin, so that's why he's able to do everything. He's already in the EKS admin, whether you add it or not, because this is the creator of the cluster. Right, so what we're going to do, we'll create a one user with name Asim, and let's say, and assume that this guy is a developer. So we are going to simply add this user, click this guy into the EKS developer. So simply click next and create this user, right? And this user is created, and okay, so simply click this user and navigate to the security credential area, and simply click this section. So what we are going to do, we are going to simply create an access key and simply click this command line section and click this section, create access keys. So we are not going to actually download it. And what I'm going to do, I'm going to create one more shell into this container. So if I do docker ps, you will see that this is the another shell I'm going to take in this sandbox, right? So I'm going to use the same user in this. I'm going to create one user. So regarding, I'm going to create one profile. So regarding that, commands are going to be there. Let's say this user is going to be this profile name is going to be Asim. So simply I'm going to export this file, and I've added all the commands here. So simply you need to copy these commands. So this is the profile name, and simply I'm going to add the credentials from here. So simply click this guy and paste it, and simply click this guy and paste it, right? So region is definitely going to be my region, US East 1, right? And let's say this JSON. And what we are going to do, simply copy the other command. So you just want to make sure that your profile is okay. So it should work, and it is working. So what we are going to do now, we are going to update this section. So you need to copy this section, navigate to the IAM section. Definitely, I need to update the account ID, but I just want to double check that this role should be created. So definitely it is created through the Terraform, as I already shown you. You just need to do Terraform init and Terraform apply. You just have to watch this particular video till end. That's what we are going to do. And if you navigate to the section roles, simply type, paste it here. So this is the role, and you need to copy the ARN of that particular role, right? So what we are going to do, I'm going to simply paste this guy here. So in fact, I've updated the name here. So you need to do exactly the same stuff here. So then what you need to do, copy this guy, and what I'm going to do, and I'm going to simply, so what I'm going to do, I'm going to cd into home, which is my home. I'm root, cd into this guy, and simply I'm going to do vim to this config. So you see this profile of Asim is created. So press O and simply right click it, paste it. So I'm going to say, I'm going to save this guy, right? And what I'm going to do, I'm going to check this STS profile. This profile has developer profile, which we are going to assume the role of that particular role we have created, and through Terraform and everything I've already showed you. And then what I'm going to do, I'm going to say configure list, use this particular command. So currently we have no profile setup. So let me set up this command, export profile, and the profile is going to be developer profile. So what I'm going to do, if I do, if I simply run this particular command, you will see that this developer profile is set up. So what I need to do from here, I'm going to simply remove this cube context. So if I do kubectl get nodes, I should get an error. Everything is, you see, removed. So what I'm going to do, I'm going to copy this same command and I'm going to import the context, right? So let's do that. So context has been added, but with regard to that particular user. For instance, we have exported this profile now. So kubectl, can I do auth? So it will say no. And if I do, can I get pause? Because I've provided additional privileges to see the logs as well. As a developer, you should be able to see the logs as well. So that is where we are going to do cost reduction in our logging area. So simply and do the quick troubleshooting. So developer and DevOps teams are going to be quickly involved in case of any issues, in case of any bugs or whatever we face issues with regard to the application, right? And what I'm going to do, I'm going to simply get out the contents. So let me navigate to this. Um okay, use this same tab, cd into mnt. What I'm going to do, I'm going to get out the contents of cube context to what this context to mnt with the name config. I just wanna use this context. You see, this context has something different in a way that you see environment, AWS profile, and this is the developer profile we are using. So what I'm going to do, I'm going to simply bring this guy into my lens, right? So I think I have the latest version of Lens is already installed. So that is how I will show you that you can, the developer can see the logs of their application. So that is pretty much in a way secure that they won't be able to delete any things. They won't be able to edit anything. But as far as the logging stuff, which is the most crucial regarding the application, from the application perspective, is really important. So we have provided those particular verbs in our applications. So let's try to access that. Okay, what I've done, I forget to, okay, this it is unable to access it because what I need to do on the host machine, I forget to add the same credentials. So it is going to authenticate. So if I navigate back to area of this AWS access key and secret access key, I need to do this AWS configure. Okay, and let's say this is my default profile. So let's try to use it and let's try to reconnect it. Okay, okay, I need to use the same profile. So let me do the same stuff in my um machine, right? So I will be back with you guys in a moment. So guys, I'm trying the same stuff which we have done in on our container, updated the lens. So it is unable to connect. So I'm going to export this profile, right? And let me do the stuff there. So you see currently, let's try to connect. You see, we are unable to connect. So let me try to do the same commands which I've done. So guys, you see I've done the same stuff which we have done on our container. So this is the same stuff which we have done in our container, and I need to do that on my host machine to make things work. So see, this is the config, and this is the workload section. So this developer has able to see net namespaces, and for instance, if this guy want to see the logs, he or she can see the logs, for instance, and if you want to delete or edit this stuff, you can do that. So we need so that is very helpful in a way that this is how we can save the logging cost, and the developers do like the UI stuff, and it would be really easier for them to see the logging of their applications. So that part is done regarding our the step which we have done regarding our two groups which we have set up through Terraform, EKS admin and EKS developer. So that part is pretty much completed. Now what we are going to do, simply uh, let me navigate to the section. So let me close the stuff which is not even required now. And in fact, let me open this in VS Code. I just want to show you some of the stuff regarding the Karpenter, right? So okay, now what we are going to do, we are going to set up the ALB Ingress. Okay, regarding the EBS, as I already discussed with you guys, if you navigate to the EBS section, you see the EBS CSI drivers are already by default comes up with this Terraform EKS manage module. So we are not installing those particular EBS CSI driver. So how we can test it? So uh, now what I'm going to do, I'm going to simply disconnect this profile, and I'm going to use the regular EKS admin profile, right? So let me do that. So simply from the setting, I'm going to remove all the stuff. So click this guy and remove this config, right? So everything is going to be clear. And then what I'm going to do, I'm going to roll back to the section and simply remove the stuff, right? So guys, in this tab, I don't have any environment exported. So what I'm going to do, I'm going to simply remove this particular tab, and uh, I'm going to simply import the context. So let's do that. And if I do kubectl, we got nodes. So everything should be with regard to the admin, right? So what I'm going to do, I'm going to simply do .cube and do config, and I'm going to simply override that particular file. So let me do that, and you will see the new context is going to be available. You see, it has no environment setup. So this guy has the full access. So simply, I'm going to import this guy in my lens. So I've shown you how you can set up or reduce the cost of your logging through this amazing tool Lens that provide those developers free. It's open source, and you can do that. So why it is unable to connect? Because I need to provide the regular credentials. So currently the profile setup on my host machine is with regard to that particular awesome user. So simply I'm going to remove that. Let me come back with you guys in a moment. So guys, I've added the credential. Let's try to reconnect it, and hopefully I should be able to connect with this cluster. So it is actually connecting, and this time we are connecting with the full EKS admin access. So guys, let's try to navigate to the pod section, and what we are going to do, I want to show you the EBS side. As I told you, this we are using the official module. So by default, I mean, the option regarding the EBS is already there. So I'm not using the Terraform like submodule, blueprint submodule to set up the EBS controller. So EBS CSI driver, which is the container storage interface driver. So let's try to test it. So simply what I'm going to do, so simply do kubectl kubectl apply -f and EBS CSI driver, and let's try to set it up. What we have in this, so um, and the I'm not going to cover all the detail, but I just want to show you the storage type should be mounted with that particular Nginx container. So if I navigate to the section default, you see currently this Nginx pod is in pending state. If everything goes well, it should be okay in running. And I'm going to show you the storage persistent volume. This is the persistent volume. You see it has bound. This is the 5 gigs, and this is the storage class. So that is why this container is running, because it has now bound. So CSI test has completed, and now we are going to do the other test. Uh, let's say, what we are going to do. Let's say I wanna test the ALB Ingress. So if I navigate to the ALB Ingress section, so we have app1, app2, YAML, and Cloudflare app1.yaml. What are these three files? So let's do one by one. So if I navigate to the section cube system, and if you navigate to this section ELB load balancer controller, so what we are going to do, we are going to simply open these particular logs of both the pods. So let me do that. So do it up. So uh, to make HTTPS work, what we are going to do, navigate to the section here, and from AWS section, what we're going to do, navigate to the section search type, search, right? Search manager, and I need to provide my domain name, and I'm going to set up the wildcard certificate for my domain. And from here, I'm going to type, in fact, Route 53. I'm going to simply click this guy. And from here, I'm going to show you the provided domain names by the sandbox environment. I'm going to simply navigate to the hosted zone, which is the actually public hosted zone. So in Route 53, you have two type of zone, public and private hosted zone. So simply, I'm going to click this guy, and then I'm going to copy this name, right? And I'm going to ask for the certificate. So click this guy, request for the wildcard certificate. Click next. I'm going to put a wildcard or star here, and press dot. Press Control V per this name. Request for the certificate. Refresh this guy. You will see the CNAME shortly available. Click this guy, and the CNAMEs are going to be this. So I'm going to copy these guys, and I'm going to create one CNAME record for the certs validation. We are going to do the DNS validation here, and I'm going to remove this particular guy from here, right, till this dot, and then I'm going to update this guy that we are going to use the CNAME, and simply copy the other section of the CNAME, which is the value, create record. So if everything goes well, we will see a valid certificate. And what I'm going to do, I'm going to do a little wait regarding the search validation. So we are going to use the SSL discovery here, search discovery. So regarding this domain, so what I need to do, I need to copy this guy and navigate to the app section, and we are going to deploy the app one. So remove the stuff. Okay, this part is done, developer is done, EBS is done. We are in ALB Ingress section. So simply navigate to this ALB section. So as I discussed, we are going to use this domain name, and the SSL automated discovery is going to be happen automatically. And simply I need to make sure the name star dot this wildcard cert, it is going to automatically discover those certs, and we are going to use this name. So simply what I'm going to do, I need to also update this area and copy this area. So if the certs are valid and everything is okay, it is going to auto discover, but we need to wait before do the kubectl apply. So if I navigate to this section, refresh, and it has been issued. So what I'm going to do, uh, I'm going to simply apply this, and I should be then f1.yaml. I'm going to apply it, and okay, I forget to create kubectl, create namespace f1, and reapplied it. So what it does, it is going to, okay, my bad, in the typo in the bug command app one. So we've created two namespaces and reapplied it. And I'm going to simply remove the other namespace, navigate to this section. You can do through the command line as well, and but you can do the through the uh, this console as well. So let me just do this stuff here. Okay, so this is wrong, and I'm going to remove this guy. You don't want it, right? So if I do kubectl get ingress in namespace app1, you see our load balancer has spin up. So if I navigate to the logs section of the load balancer controller, it will be okay. It will say registering targets. So if I navigate to the section, okay, navigate to the EC2 section, click this guy and navigate to the load balancer section. You will see the ingress rules, target groups. I'm going to show you quickly. And some of the other stuff regarding the annotation I've added in other files, I'm going to show you. Those are regarding the security. And if you are using the Cloudflare, you can use those particular IP addresses. If you're using VPN, for instance, if you want to allow your website only through that particular VPN IP address, you can do that as well. I'm going to show you shortly that particular stuff. So navigate to the load balancer. You see it has been created. So we have two listener 40 and 80 and 443. Click this guy. In the next tab, you will see the rules as well. So let it open. So this is a 443 listener. They AWS have updated their UI. So in this section, you will see the details, and in this, you will see the rules. And we are using the path-based and host-based routing. So if the request come to from this um, subdomain routed to this um, target group, in that target group, we have our application. It should be healthy. So if we scroll it down, you see target type IP, and simply I'm going to paste this guy here. So okay, one thing it's not going to work. One thing I forget. What you need to do. Create a DNS entry. So we are not doing the automated DNS entry. If you want to do the automated DNS entry, you can watch my particular video regarding the automated DNS entries in the Route 53. So simply copy this guy, navigate to sorry, sorry. In the create record, I need to copy the load balancer DNS. So navigate to the load balancer section, copy the DNS, which is the DNS name. And if I click this guy or simply click this DNS name, So navigate back to the section, type app one, make sure there should be no typos. You can set the alias. Let's try to, let me show you how you can set up the alias. Click this guy. Endpoint is going to be your application load balancer. Region is going to be US East 1. Copy this guy, and the application load balancer is going to be automatically populated here, and create this particular record. So, okay, guys, so let's do that. And by doing that, if you simply copy this, if you click this guy and navigate to the section, you will see the multiple A records with regard to the ALB is going to be available. So if I type what is my DNS, I can do NS lookup as well, but you can use these online useful websites as well. So if I do look for the DNS propagation, search for it, and you see the multiple IP addresses. These are the IP addresses, a record of the application load balancer. So let's try to access these. So by default, it will create 80 and 443 allow in the security group. So we need to wait for a while. As I discussed, the DNS propagation will take some time. So let's try to simply access it, or simply use the incognito mode as well. Or let's try to use this. We need to wait for a while. Okay, so, and one thing regarding your machine, you just need to be make sure that you can use the cache only DNS. So let me do run, okay, do instead of Resman, do ncpa.cpl. Okay, mistake, typo, and I'm just gonna use the Google cache only DNS, and this one's 8.8.8.8 and 8.8.4.4. Save it, close this guy, back to this guy. Let's try to reload, and it should work. So if you face these sort of issues, this is a quick tip. You can do that. So guys, this is our application mode regarding the UC secure ALB Ingress controller. Instead of manually installing it in our past videos, we have set up through the EKS blueprint submodule. So regarding the other stuff in, for instance, app 2, it's pretty much the same. The application is different, but if you see the cloud player, I'm not going to do all the stuff, but I'm going to show you what you can do with it. For instance, I've added the annotation here, the geo stack, and added the inbound side ranges, which are IP version 4 and IP version 6 of Cloudflare. You can use the additional security. The traffic is going to be routed through the Cloudflare, and it's going to be got bit much more secure that you need to make entry in the Cloudflare. And other option you can see, for instance, I want to see my IP. So let's try to apply this. I just want to show you this example, right? And so let me do that. And this is with regard to the, for instance, you have your VPN, you want the ALB ingress to show that particular traffic. So what it is actually doing, it is making the ingress rules in the security group by allowing the traffic, allowing that particular IP address. So instead of manually doing the stuff, you can do and the automated way through through these annotation, right? So okay. So okay, let me copy this guy, and I need to update this guy. update this guy, right? So instead of app1, so what I'm going to do, I'm going to put wildcard here, right? And let me do that. So I also need to, let's say call this, also it's gonna be, let's say app3, okay, to make sure we should have no issues. And the IP address. What is my IP? So if I do go if config if config.me uh, config.me. So this is my IP address, public IP address, right? I just want to allow the traffic from this IP address /32, right? Right. So okay, everything seems to be okay. So let's try to navigate to the section. If I do ls and kubectl apply hyphen f cloud flare. I mean, this is, you can say that it's a VPN, and my VPN address is this, and I want to secure the traffic. And what it does, it is going to allow traffic only from that particular address. So okay, okay, so what I need to do, I need to make sure I make an entry in my DNS, and if I navigate to the DNS section, and let's try to simply edit this particular role instead of new entry, and let's try to save it, and let me do the update here. So I need to wait for a while till the propagation happen. So till then, I'm going to pause the video, right? So guys, I'm back. One thing I need to update you. I mean, I've provided my IP address to make sure if you have provided only the IP version 4 ranges, so you have to make sure you command this dual stack, because with the dual stack you need to provide that version 6 ranges as well. So for instance, this is your VPN address. So let's try to access it, and shortly, once the propagation is happening, you see the entry is already there. But what I've done, I've updated the load balancer, so I need to update the DNS record. So what I need to do, navigate to the record section. So simply, I need to update the entry here. So I've removed the previous load balancer for just for make sure that everything goes okay. So regarding the alias, to application load balancer, and simply remove this entry. So only one entry is populated now. So simply save it, and let's wait for a while to make sure everything is okay. So this is our the dual stack. I mean, our load balancer. So let me refresh it, and let's try to access this guy. Sorry, this one. You see, it is fixed. So this is the way you can simply allow, from the security perspective. This is not publicly available. For instance, if I change my IP addresses to different IP, this is not going to be work, because if I navigate to the security group section, so let me do that as well. So that is important for your understanding. So if you navigate to the load balance section, navigate, okay, click this guy, click to the security section. You will see the two security group. One is going to be okay. So let me refresh it here. So Okay, let me refresh it because it seems to be the old tab. And as I discussed, I've removed the old load balancer. So simply click this guy and navigate to the security section. You will see the two security group. So let's open that. In one security group, you will see no ingress, and the other security group you will see, and the ingress 80 and 443 are going to be only available from my IP address, or you can say your VPN address. So see, this one is empty. So let's check the other one. So click this guy, scroll it down. You see the port 80 and 443 has my IP addresses, or you can say the VPN address. So if you can connect with the VPN, you can simply access this particular application load balancer, which is the ingress to your VPN. So this is one of the security uh, annotation you can use through Ingress. So I've done some additional stuff. It's just not regarding the installation of ALB Ingress controller through the submodule of blueprints, and I've shown you some of the stuff which you can do and which is actually required. So in the last, I guess we can do stuff with regard to the Karpenter which is left. So simply navigate to the section, open the logs of the Karpenter. If you navigate to the section pause, navigate to the Karpenter section, you will see two logs. Currently, you will see errors, and those errors are because we have not actually applied the settings. So let me show you the stuff. So this is the info, and if you see these particular logs, you will see the error, and that stuff. So simply fix this. So simply we are going to the last step of our setup. So you can do a lot more with this sub module. There are a lot, I mean, they are actually including a lot of stuff here. So what we are going to do, if you want to see the detail regarding the Karpenter, I've already shown you guys the video. You can watch those. So simply I'm going to apply this file. I'm going to show you what these files are. So here we have the default provisioner and our app custom provisioner. So if and let's close the other stuff which we have actually finished, we are now heading to our towards our last step, which is the Karpenter. So this is our custom provisioner, right? And I've covered the detail. We are going to use the T3 medium spot here section here, and this is the default stuff. So I've done the apply, but I forget to add one thing here. I need to provide the instance profile. The instance profile I can get simply by copying this file, right, and paste this file in your CLI. So you will see one profile which is going to be of this node group on demand node group, which is the managed node group. So I'm going to copy this guy here, and I'm going to simply navigate to this section, and I'm going to do a reapply here because that particular file does not exist. So profile. So simply quit here and let me do the reapply here. So this is the profile which we are going to use, and this is the instance profile, and from the custom provisioner, we are actually calling this I mean, default provisioner. So in the app section, so we are going to, I mean, use this particular, sorry, uh, this app, right? So this is the app, and we are going to do port forwarding to this app on our local machine, and let's do that. So, and we are going to do some of the load testing on this machine, and we are going to do the scaling as well on this particular um, pod. So let's try to apply this stuff. So let's do CD into this app. So kubectl apply. I can apply this app. Okay, this pod is created. Along with that, if you see kubectl get HPA, And one thing I forget, we are not just doing, we have set up also the matrix server. We have installed the matrix server as well. kubectl do top pods in all namespaces. You will see the CPU utilization and the memory utilization of these and those particular pods of all pods which are required to get the HPA horizontal pod or scalar to work. So first of all, I need to show you the stuff with regard to the scaling. So if I navigate to the section default, and this is the app we have uh, deployed 57 seconds ago. So let me try to scale this guy. Let's try to scale to okay 55 pods. So let's see what we have got regarding the instance creation. Do we have our pod still stuck in pending state, or uh, okay, max set up of replica is 10. So okay, max replica is set up of 10. So let me do change this guy to 100, min max to this guy. I mean 1 to 100. So let me do apply F1 YAML. So okay, then if I scale it down, scale that particular guy to okay, simply scale that guy to let's say 46 pods. So you see, launch new instances. So if I navigate to the UI EC2 section, I just want to show you how the Karpenter work. I mean, regarding setting, if we have done, we have set up our custom provisioner. See, it has launched our custom provisioner. So you see the name of that provisioner is app. You see, initialization of those pods, I mean, of those EC2 machine has done quickly, and those pods are going to be simply move from from pending to running state. So you see the huge list is going to be available. So I'm going to simply scale back to this one section, and well, I mean one TTL is going to be set up. So instead of 0, put it 1. So you will shortly see in the log section, these logs are actually of the Carpenter. I've intentionally opened these logs. So it is very easier and gives us more flexibility to see all the logs. Shortly you will see the TTL has been set up to those particular nodes, and shortly those particular nodes are going to be deleted. So let me close the other tab, and shortly you will see that those particular nodes are going to be removed. So we have to wait for a while. So the TTL default I've set up, I guess, is of how many seconds? So is of 60 seconds, which is 1 minute. So okay, let me scale it down to 0, but I have to do it from this area. Okay, navigate to the section app and simply move this guy to 1 to 5 because we are doing the changes from the application. So apply these changes from 1 to 5. Okay, and let's try to scale to okay, simply cancel it. And now we are back, and you will see shortly because the TTL has been added and TTL has been removed, and shortly you will see um, TTL is going to be added, and those nodes are going to be removed. So currently we have running nodes 5, and the additional ones are Karpenter, but we don't have any, stuff. So the max applications are pods are 5, so it is going to simply remove the additional nodes. So it is going to be done quickly, so we have to wait for a while to make sure that everything is removed. So let me pause the video. Till then, I will be back with you guys in a moment. So guys, if you see the logs, TTL added to the empty nodes, and then coded nodes, and then deleted nodes. So let's navigate back to the section. You see the nodes are in delete state. So Carpenter is working fine, right? And that is pretty much regarding the stuff we are looking for. And in the last, what we are going to do, we are going to port forward to this application, and let me do the updates. So let's try to add uh, 10 nodes, right? And CPU utilization, memory utilization, change it to 80, and let's try to apply. So I just want to show you or highlight this is the autoscaling or horizontal pod autoscaler version 2. You might be using the beta, but this is not going to work in the I guess version 1.23 or 1.24. We are using the version 1.25. So let's try to simply apply this app.yaml. So it has configured, and let me navigate to the section pods and deployment. Okay, so from the console you can see the namespaces, events, and regarding the configuration, you will see the limit range, the HPA. Okay, so let me close the logs of the Carpenters. You see, this is our HPA which we have set up, the min, max, pods, and replicas. So, and what we are going to do, we are going to do the port forwarding to this guy to if I navigate to the service section, you will see that it's service, and okay, we have not set up the service, so we have a deployment, and 4 pods are going to be running because the CPU utilization, I mean, of the pods, uh, make it increase from 1 pod to 4 pods. So if I navigate to this section, you see min replica and max replicas are 10, but the CPU utilization of those particular pods, if I do kubectl top uh, pods in namespace default, CPU and memory utilization. So currently the memory utilization is 10 M, and after few minutes, it is going to reduce to 1. So if I do I mean, if you send the load to this particular pod, let me do that. And if I do curl, so first of all, I need to make sure I do the port forwarding to kubectl do port. Let's quickly do that. Do port forward, and dash dash address is going to be 0.0.0. Okay, port forward to let's say this port, right? And let's do that in the namespace default. So okay, I might be misspelled. Port for kubectl port forward. Okay, instead of address should be okay. I forget the port mapping as well. So let's do the dash dash address. Okay, and the port mapping is going to be port mapping like this way to my container. So if I do open another tab, and if I do exec into this particular container again, so if I do curl -v and telnet to this local host, I should be able to connect with this port. You see, it is connected. So if I do curl local host and port 80/CPU, and let me open one more tab here, do exec, do kubectl top top ports in namespace default. I just want to show you the difference in, you see, the CPU and the memory usage. So if you hit this particular target, you see, slash CPU, and if you simply hit this target memory, you will see that the difference is going to be available. You will see the difference in the memory and CPU utilization shortly, but this will take some time. You need to wait for a while. You see the CPU load has gone, and in fact it brings, but you see the memory has load rises. In past, we have when we hit that particular URL, our load has increased. So kubectl get pods. So we have updated the values. So if we increase the values, so we will see some of the, see, old pods are terminated and new pods. Some of the stuff, as I discussed, the old pods are terminated. New stuff is going to be actually able to handle that CPU and memory utilization. So this is regarding the horizontal pod autoscaler. So these are the limits. Let me change. You see, I've updated the limits from 80, from of the memory limits. I've updated to 80 and CPU utilization 80. You can reduce the limit and do the testing through these particular endpoints. So currently, I've not set up the Prometheus. In past videos, I've set up the Prometheus and showed you. You can see all the CPU and memory utilization of pods in this area of lens. So you will see the Prometheus not set up. So I've already made videos with regard to that. You can watch those particular videos. So guys, if you like the video, please like, share, and subscribe the channel. Have a nice day. Thank you.